to be providing a quick overview of the bioinformatics training platform that we've developed in Australia for delivering hands-on training for next generation sequencing to Australian researchers um, that we've been using since 2012. So the first slide I'm showing here is basically just the high level overview or the big picture of the whole process and steps for setting up a training workshop. We can see in here that basically the workshop is composed of various components that are uh, used by the system to be able to deliver a identical environment across multiple clients for that contains the relevant tools and data sets and desktop environment. So a typical user or an administrator for a workshop will normally create new training images for the cloud as well as standalone images for each workshop, which happens in Australia roughly every 6 months. These images are available on the Research Cloud that's been available for Australian researchers, but it can also be accessed by users on their normal desktop or laptops by simply downloading the created training images for VirtualBox or VMware. At the end of the day, each workshop will be composed of multiple training instances that will be launched prior to the actual day of the training. So most of the time, the trainees doesn't actually know that the training environment that they're using are running in the cloud. It's only after the workshop that we can actually introduce them that, yeah, this is running remotely and all the processing is done not on the actual physical computer that they are sitting on, but on a cloud resource available for them to reuse on after the workshop. So this is a typical desktop environment that users or trainees see when they're doing the hands-on training. As you can see, it's a standard Linux-based environment with all the relevant training modules and tools available for them to use. In the early stages of the Research Cloud back in 2012, 3 years ago, there's only a limited number of institutions in Australia that provides research cloud infrastructure for researchers. So most of the time, we've generated or created training instances on the cloud running in a certain area of Australia, but it's actually being accessed by trainees or users remotely from a distant location. They don't get any sort of performance hit on when even though they're accessing it from far away regions of Australia because of the research network infrastructure that's been laid down between various research institutions. So the Research Cloud utilizes this network infrastructure for delivering close to 100% performance in terms of remotely accessing the instances from different locations. So the training environment is based on a flavor of Linux, which is Ubuntu. So this is quite a popular Linux flavor for high performance computing as well as um, standard desktop environments. So when there is a training workshop happening, we ensure or the administrators, organizers of the training workshop allocated 1:1 resource allocation for the users. So each users will get access to a dedicated training VM And also, all the training modules are prepared and automatically installed into this training environment. We can see here the standard specifications and requirements that we have come up with based on our previous workshops, depending on what kind of workshop is going to be done. For introduction to next generation sequencing, we've been using a 2-core 8 gigs of RAM configuration for each of the training virtual machine. And for the more advanced or more computationally demanding courses such as cancer genomics, we are dedicating 4 CPUs and 16 gig of RAM for each of the training virtual machines. In a typical environment, in a typical training workshop in Australia, trainers from various institutions go basically travel to the workshop venue, and they are presented with this kind of environment. It's basically like a training computer lab where there is one computer per user. Each of these computer is accessing an actual virtual machine running in the cloud, and they are all one is to one, so they are dedicated to that specific user, and no one is sharing other resources. So this ensures that each one of the users have a dedicated resources, so they don't have any competing resource needs if they are running some computationally intensive jobs for their hands-on sessions. The training workshops that's been developed for the training platform have been designed to be modular, and in terms of um, providing flexibility and capacity to update the workshops as per required for the actual training. So we can adjust, or we can add new training modules also, but also we can also shrink the workshop by removing not needed training modules. So this flexibility allows a training workshop organizer to customize the workshop specifically for the environment or for the audience that they want to deliver the training on. We've also developed orchestration or automation system for creating the training images for the cloud, as well as desktop virtualization software such as VirtualBox and VMware. And all of these system orchestration scripts and manifests are available on the BPA CSRO workshop repository on GitHub. Um, in the next couple of slides, I'm just gonna provide some overview of some of the components or some of the technologies that we've been using and we've utilized in the development of the training platform. Like I mentioned before, all of our code, all of our orchestration setup and scripts and programs are all version controlled and available publicly on GitHub. Um, we are using Travis configuration integration, continuous integration for automated building and compilation of the training handouts. Each training module in a workshop basically has a latex-based handout that has been developed by organizers, but it's a collaborative effort. So there's gonna be more than one users who's actually develop the content of these handouts, and each training workshop there are minor or major changes that can be done on the handout, and once these changes have been pushed and approved into the repository, Travis recompiles the handout to ensure that the handouts are in a good quality and available all the time. So the The training images that we use for the cloud as well as the desktop environment are all orchestrated and automated using Packer. Packer is a open source, freely available tool to create identical images that anyone that can be used on the cloud environment as well as on this desktop-based virtualization applications such as VirtualBox and VMware. We have also used a nice tool called FPM and FPM Cookery. So this allows us to package analysis tools. Most of these analysis tools are built from source into a easily deployable software installers compatible for the operating system that we're using, which is Ubuntu and Linux. We've chosen this tool because some of the analysis tools that we are using on the training images and training instances requires customization. For example, we need to compile a certain tool with certain flags to make it optimized for the data sets that's going to be covered during the handout, during the training hands-on sessions. So this tool makes it easier for us to distribute those packages as just a standard installer that can be installed pretty quickly on a Linux environment. We are using Puppet. Puppet is a configuration tool used by many enterprise and big companies for configuring automated configuration of physical machines, physical hardware or servers, but it can also be used as a configuration tool for automated configuration of virtual machines, which is what we're doing for the cloud deployments of the training images and training instances. Um, for the cloud environments, the most of the cloud infrastructure available commercially as well as freely have a orchestration system that is available for the users to deploy applications with a use of a template. For the research cloud, we are using OpenStack Heat, which is what is the research cloud is based on the OpenStack open source software. And for Amazon, we're using AWS CloudFormation. So we have developed templates that are compatible with this orchestration service so that it allows easier and faster deployment of training instances on this cloud environment. Like I mentioned before, all of the materials and components of the training platform are version controlled and publicly available. The training modules are basically organized into separate repositories for each one, and each repository has an underlying data directory structure, as you can see here. So each training module will have its own dataset and tools configuration. So this allows us to basically design a modular system for configuring specific contributors to the content of this training materials can push and um, contribute their changes on. The training tutorials or handouts, like I mentioned, are based on LaTeX, which is a nice way for formatting and configuring the handouts in such a way it can be easily followed by the user or the trainee during the hands-on sessions. And we've developed certain formatting and encoding for the LaTeX document that can be easily reused with the use of our guide and templates available for the users. The training datasets that are described on each training module are actually stored on the cloud and are publicly available as well. We made this available on both the Amazon commercial cloud object storage, as well as on the Australian Research Cloud object storage. Um, when a user launches a training instance on these cloud platforms using our orchestration templates, it the templates are automatically configured to pull down the training datasets for each training modules and install those datasets into the training instances. So these training datasets will be propagated into the training instances, ensuring that all of them has access to the training to the required datasets to perform the hands-on sessions. The training datasets, like I mentioned, are described in each training module and represented on GitHub on their GitHub repository using their dataset metadata. These are basically just text file based configuration files that describes where the datasets are stored and where to install them on the images as well as on the training instances. So this is an example of that dataset metadata file, and this is an example for downloading the object file from Swift, which is the object storage service for the Research Cloud in Australia, and it describes where to install it using the target lines in this file. Like I briefly mentioned regarding the tools that we are using for the training, we are using FPM system for automated creation of installers for each one of these analysis tools. So this FPM cookery is written in and inspired by the Brew application that is available on Apple and Mac machines, and it creates a installer or a dev installer for each of the tools that we are customizing, and these installers are then are easily configurable to be installed on Ubuntu or Debian-based Linux environments. Um, this is just an example of a tool recipe that we are also maintaining and develop for the training platform. So in this example recipe file, it is basically telling the FPM cookery tool to download the source code for Velvet, and using the build blocks in here, it tells the tool to compile Velvet with these certain compilation flags. And once it's been compiled, it will then create some aliases for some of the Velvet executables, and it tells the installer to install these executables into the system executable directory on each once the installer is ran. These tool recipes are again also publicly available and maintained on GitHub, and we most of and each one has their each tool that we are including into training instances and training images has their own recipe available for them. And so each one can be configured, can be customized if required. For example, new versions of certain tools are available. So each specific tool recipe can be customized if needed. This is just a screenshot of the tool recipe repository on the BPA CSRO GitHub project. So the once the training modules have been installed and with its corresponding datasets and analysis tools are configured, it basically creates the training images that can be packaged up and made available for the cloud as well as desktop environments. So it the system is designed to make it easier to configure the final image by simply removing or adding training modules, or of course adding or train or removing data sets within a module. Same thing as for the analysis tools. The BTP images or training images are basically created using the Packer tool, like mentioned, and it's made available for the Australian research cloud called NECTAR, as well as on Amazon, and also as a downloadable and standalone image for VirtualBox and VMware. So the Packer tool uses a simple recipe for building the training image, and it's also fully automated. It can be used as is, but can also be customized to certain requirements for a upcoming workshop. So this is just an example of a recipe that is used to build a uh, virtual machine image compatible for the Australian Research Cloud. So I'm just gonna quickly go through provide a summary of the reusable resources or components for the training platform. Basically, all of the components are reusable. The images itself is created using Packer and using a build recipe that can be rerun, customized, and recreated depending on the requirement. The training workshop itself is composed of training modules, where each training module has its own corresponding training datasets and analysis tools, as well as training handouts. And each one of these subcomponents are available on repository as is, can be used as is, but it can also be customized and reused if needed. This is just a quick overview of how these images are used and launched on the Research Cloud. So the orchestration system that we have developed and available on GitHub uses all the information in the each of the training modules and configures a virtual machine image with all those underlying tools and dataset configuration. Then once it's finished configuring the training running image, it is then made available into the cloud providers as well as into a standalone VirtualBox or VMware desktop images. The orchestration templates are used to launch these training images on cloud. It could be on Amazon or in our Australian Research Cloud, and it's also again a easy to configure file ASCII file based text based template that can be customized if needed. On the Research Cloud, we are using the orchestration service based on Heat, which is an open source project, and it uses all the tools that I've mentioned before, such as Puppet and training data sets and analysis tools, metadata to basically configure the training instances for the actual workshop. The NECTAR Research Cloud allows a user or an organizer in Australia to be able to distribute the resource or training instances across multiple availability zones. But most of the time, we basically choose the availability zone closest to the training environment where the workshop is going to be held. It's a dynamic provisioning service that allows a user to request allocations and to be able to use their allocations on demand and with minimal expertise on system administration. So this page just a overview of some of the typical scientific applications that has been running or have been deployed on the Australian Research Cloud. And this just shows you the growth of the infrastructure that's been made available to Australian researchers since 2012, 2013, and it's continuing to grow due to popular demand for on-demand provisioning of cloud infrastructure. Most of the time, users doesn't even need to use command line or API to create their own virtual servers on most cloud infrastructure. And for example, here on the Australian Research Cloud, we're using the web-based dashboard for launching the orchestration stack that we are including in the workshop repository. And using a simple web-based form, user just need to complete the minimal and required um, information to be able to launch a training instance for their own use or for a workshop. Recently, we've been given Amazon credits to help us to deploy the training platform on AWS. We were able to manage that, and we were able to replicate our configuration and our setup into the Amazon cloud environment, initially only available on the Sydney region of Amazon, but we've also made this available now recently on the other regions of AWS. So as you can see here, it's available in Sydney as well as in AWS in Europe. But the image itself that we have developed for the training platform can be easily manually copied by a user interested to reuse our training image. This is just a screenshot of the Amazon Web Service dashboard, similar to the Research Cloud dashboard that I've shown you before. And this is provides an overview of all the services available for the user. And this is just a screenshot of a stock stack creation, which basically uses the orchestration template we developed for AWS to launch a single or multiple instances for the training environment. Accessing the instances for the actual training is normally done using a remote desktop if we are using the cloud infrastructure providers. We only need to install a single application on the actual physical computer of the training lab or training site. As long as that computer has access to the internet, then it will be able to connect to the application, to the desktop environment of the training virtual machine running on AWS or on the Research Cloud. Post workshop, we actually instruct users that the environment that they've used during the workshop can be accessed and reused for them to be able to refresh their training knowledge on the tools and datasets that they've learned. And we are providing a landing page available on the website, as well as information in the form of a step-by-step guide on our GitHub project repository that allows the users to go through and launch their own instances on the Australian Research Cloud as well as on Amazon. So to summarize, I've just provided the components that create that combines create the bioinformatics training platform that we have developed in Australia and have been using for the last 4 years to deliver hands-on training workshops to Australian researchers from various locations, various states across Australia. We've developed the training platform to be modular and plug and play fashion, so that it allows users to basically create their own workshop or use the existing workshop as is, but allows flexibility for customization, such as adding new training modules or customizing datasets analysis tools for each training module. We have developed orchestration services as well as automated scripts and templates for easier creation of training images as well as launching of these images into a training instance. And all of these are available publicly as open access on on our GitHub project as a public repository. In the future, we've been engaging with AWS to make it even easier for the training platform to be reused and to be accessed by users. And we are looking at making it available on AWS Marketplace and also making it available on the Research Cloud Marketplace or App Store for Australian researchers. Well, we are also looking at ways of making it easier and more lightweight, such as making it available as a Docker image, but we're also looking at, depending on requirement and demand, to make it available in other commercial cloud providers such as Google and Microsoft Azure. And we've been engaging with various facilities across Australia on how to make the environment production ready so that the analysis tools are available and orchestrated in terms of installation to make it easier for facilities to adapt these tools to their environments. So this will involve collaboration and data management features as well. So these are just the links to our BPA CSR project on GitHub and provides you some information of all the repositories that we maintain, as well as the landing page for getting started really easy on how to use the training platform for developing new workshops or reusing existing ones. And if you get any questions, you can you can send us an email for Annette from CSRO and for me, Jericho from Monash University. Thank you.